ダイエットコクとメントスのみ友達は引き裂かれるさこで消えてゆくと
Minasan ohayo gozaimasu. As you all saw, when you drop Mentos into Diet Coke, it explodes into a furious geyser. It's clear that nothing but a violent chemical reaction could cause this.
Yeah! バカ! この花は科学的ではなく物理的です!
Tanya Coffey in the American Journal of Physics says that the fizz in Diet Coke is dissolved carbon dioxide gas. Usually, the surface tension of liquid is high, so bubbles can't form easily as water molecules like to be next to each other due to capillary forces. Bubbles can only gather around a nucleation site where the network of water molecules was broken up. According to EpiBird, although Mentos looks smooth, the surface of a Mento is full of microscopic irregularities. The carbon dioxide molecules form bubbles in these cavities in a process called nucleation, which then rise to the surface, according to acs.org.
Nani?
The Solugen team explains how the rising bubbles push the liquid out, causing the explosion. Mentos simply catalyze the release of gas from the Diet Coke.
Therefore, the reaction is purely physical!
According to Scientific American, carbon dioxide's bonds with water must first be broken for it to interact with itself. Lucy Bell Young of Reagent argues that several chemicals are responsible for this reaction. The acidity of Diet Coke dissolves the Mentos shell, releasing surfactants like sugar, aspartame, and potassium benzoate, which break these bonds and allow carbon dioxide bubbles to form.
The reaction is chemical! Dissolution is a physical process. Therefore, the acid dissolving the Mentos shell and the overcoming of intermolecular forces aren't chemical at all. They're physical! You will never win!
You're full of lies!
Butsuritaki!
Garaku!
Butsuritaki!
Garaku!
Butsuritaki!
Minasan, kono ronso wa tanjun desu. If the reaction is a chemical change, the CO2 would have been chemically bonded in some compound, increasing the soda's boiling point before the reaction. However, if the CO2 is only physically disintegrated, the boiling point would be lower before the reaction according to Shandu of ResearchGate. Therefore, all we need to do is compare the boiling point of the soda before and after the reaction. And then we'll know if it's chemical or physical.
Atamahi! But how much energy is released in the reaction?
Nethaniel,
Hi, Senpai.
show 'em what you got.
We could just use the good old formula PE equals mgh, as whatever energy released must have been translated into potential energy at the geyser's maximum height. We started with 2,000 milliliters of soda, with around 670 milliliters left, so about 1,330 milliliters were launched. According to all science fair projects, Diet Coke has roughly the same density as water at 1 gram per milliliter, to have a final mass of 1.33 kilograms. Earth's gravitational field is 9.81 meters per second squared. Finally, we could subtract the final height from the original height for the total change of 4.8 meters. We're only using one significant figure to reflect uncertainty with the volume of soda ejected, its density, and its maximum height. Thus, the amount of energy released during the reaction is around 60 joules.
彼らは本当と知りません。それは実際には三塩基反応。
NANI?!
Llama?
どのくらいかかりましたが私たちの違いのために血が流れるそばにいてください